In this movie, we'll look at how you draw a basic sequence diagram. The things that you need in order to create a sequence diagram are lifelines, messages, and executions. We'll include signals as well here to explain how they differ from messages. Sequence diagrams are one of the types of diagram in UML that you can use to model interactions. Lifelines represent the things that are interacting in a sequence diagram. They're usually instances of objects. They're shown in the diagram as a rectangle with the name of the object in it. There's a line down the page from the head of the lifeline, which is usually dashed. When an actor is interacting with the system, a lifeline is also used for the actor, with the actor stereotype of the stick person at the top. Lifeline names reflect the fact that they're objects. The name can be the name of an object. If the object is part of some kind of array or collection where the multiplicity could be greater than 1, then there may be a selector that identifies which instance is being referred to. The name could be the name of the class or interface or other type that's participating in the interaction, in which case it's preceded by a colon. The name can also be a combination of the object name followed by a colon and the name of the class. Time in a sequence diagram runs down the page from top to bottom. The fact that one event is lower down the page than another implies an ordering of events, except in certain circumstances to do with parallel events. However, there's no scale to these diagrams, so the distance between events on the page doesn't represent the length of the time between events in the interaction. Lifelines interact by sending each other messages or signals. There are different kinds of messages represented by different styles of arrows. A creation message results in the creation of a lifeline and is a dashed arrow with an open arrowhead going to the rectangle at the head of the lifeline. A synchronous message represents a synchronous call, usually of an operation of the class of which the lifeline is an instance. A reply represents the return from a synchronous call, and possibly the return of results. An asynchronous message represents an asynchronous call, usually of an operation of the class of which the lifeline is an instance. A deletion represents a call that results in the destruction of the lifeline that it's sent to. In the early stages of a project, typically during analysis, the names used on messages can be informal, reflecting the fact that the operations may not have been defined, but the analyst has an idea of what the intent of the message is. For example, a message requesting the change of dates. The formal syntax is shown here and is available in the UML specification. What this means is that a message is either a request message or a reply message, or the asterisk that represents a message of any type. Again, here's the formal syntax of a request message. Usually it's a call of an operation on the target lifeline, and may include argument values or the names of the argument and their values. So here, the message represents the change dates operation of schedule with the start date and duration. Reply messages are often left out or left unlabeled, but here's the formal syntax again. What this means is that you can show the assignment of a return value to an attribute or variable. If you're working in an environment where the programming language is known, and that language supports the passing of parameters by reference, and then those returned parameter values being used, you can include assignment of parameters inside the brackets as well. Signals are used when a signal is being sent over a communication link rather than a message invoking an operation through a call. The arguments of the message correspond to the attributes of the signal, as in this example. X10 is a protocol for communication to devices in a home automation system. Signals are shown with the same notation as asynchronous messages. Execution specifications, which were called activations in earlier versions of UML, are shown as a rectangle on the lifeline. They represent the execution of some action by the lifeline. This would normally be carrying out the operation that's invoked by the message, or responding to the signal. The executions can be overlapped to represent where one lifeline sends a message to another lifeline, which calls back and sends a message to the source lifeline before replying to the first message. Let's have a look at how to create sequence diagrams in Enterprise Architect. The first sequence diagram we'll produce will be in order to specify some of the functionality of a use case. We'll start with use case Add a Device in the Configuration use case diagram. I right-click on the use case and select New Child Diagram, and then Interaction, and then with Sequence Diagram. I'm creating a new element within that use case, and it's prompting me for a name. I'll give it the name of the use case. So the interaction is getting the same name as the use case in this particular situation. Here's the blank diagram for a sequence diagram. The first lifeline I want to add is the actor. So I'll drag the actor engineer from the actors package into the diagram. It prompts me to know how I want to add it, and I'll select Lifeline from the drop-down list. You can see the lifeline's been added to the diagram with the actor icon and the name :engineer at the top. I'm going to follow the model view controller pattern, so I'm going to add a controller object to manage the interaction. I'll add a lifeline from the toolbox and call it controller. This has an object name, but no class name. This highlights the fact that in my analysis so far, I haven't identified classes outside the domain. I'll add a new package to my class view called controllers and create a class diagram in it. Class diagrams are structural, so I select structural on the left and class on the right. So I've created a new package, and in that diagram, I'm going to add a new class. I'm calling it Add Device Controller. I know that I'll also want to add a user interface class, so I'll add a package called UI. This will also have a class diagram in it. And I'll add a class here called Add Device UI. Now back to my sequence diagram. Now I can set the type of my controller lifeline to be Add Device Controller. I right-click, select Advanced, and then Instance Classifier. This is exactly the same as in an object diagram when we selected the class of an object. In my class view, I open the Controllers package and select Add Device Controller. You can see that it's added the name Add Device Controller as well as the name of the object to the lifeline. Now I'm going to add the user interface lifeline. Rather than adding a lifeline from the toolbox, I'll show you another way of adding a lifeline into a diagram. In the same way as I did for the actor, I drag the class Add Device UI into the diagram and select Lifeline. This time it's got a class name, but it doesn't have an instance name. I'll give it the name GUI, Graphical User Interface. So at this point, we've added the lifelines into the diagram. We'll pick up here where we left off in the next movie.